we can extend that idea to another matrix here. So we have matrix A, we have matrix B. So we want to find AB and then BA. So AB is simply A times B, so we shall say matrix A times matrix B. So the matrix A is here, the matrix B is there. So we just, where there is A, we put that value. Where there is B, we put that value. Now we are going to use the same concept of multiplication. We are going to multiply row by column. So I'll get this and multiply it into this row into this column. So I will take 2 times 6 plus negative 1 times 10. Then next 0 times 6 plus negative 1 times 10. Let me repeat, 2 times 6 plus negative 1 times 10. Then I proceed to the second row. 0 times 6 plus negative 1 times 10. We don't end at that. I will again get this 2 times 8 plus negative 1 times negative 12. 2 times 8 plus negative 1 times negative 12. And then finally we shall look at the second row, second column. So 0 times 8 plus negative 1 times negative 12. Now once we get to this level, the remaining work is just computation. So this is 12, this is negative 10 giving us 2, this is 0, this is negative 10, this is 16 plus 12 giving us 28, this is 0 giving us 12. So the second question, B times A, shall use the same approach. Put the matrix B, put the matrix A. Now we use the same principle. Let us now retrace the steps we did in the previous question. So we shall take this row into this column. First row, first column. First row, first column. First row, first column. First row, first column. So 6 times 2 plus 8 times 0. Now I come to this 10 times 2 negative 12 times 0. We don't end at that. I must also get this row and multiply it into this column. First row, second column. So 6 times negative 1 add 8 times negative 1. Do the same thing for this row. 10 times negative 1 add negative 12 times negative 1. So we shall end up with, that is 12. So we do computation and we end up with those values. So the most important part as far as matrix multiplication is concerned, we need to always remember that when you're multiplying matrices, you always multiply a row into a column and you must exhaust all. First row, first column. First row, first column. First row, this is the first row, I multiply it into the first column. This is the first row, I multiply it into the second column. I go back to the second row. Now this is second row, first column. Second row, second column. And you come to that. And that is the only principle we apply when we are multiplying matrices. So when you check A and B, then B and A, you realize that in matrices, A times B is not the same as B times A. So when you multiply A and B, then it will not be the same as B times A. That property only applies to matrices, that A times B is not the same as B times A. We can now take the next question. We have a matrix P there. We have a matrix Q. And then we have a matrix R, which is P times Q. So we can study that question. before we begin answering, you can try to investigate what is the order of matrix P. Ask yourself that question. What is the order of matrix P? How are you going to derive the order of matrix P? You look at the number of rows. How many rows are in matrix P? And how many columns are in matrix P? So this is row 1, row 2. So it has 2 rows. And how many columns? 1, 2, 3. So therefore, matrix P is a 2 by 3 matrix. 2 by 3 meaning that it has 2 rows and 3 columns. How about matrix Q? How many rows do you see? Rows are horizontal. So this is the first row, second row, third row. First column, second column. So meaning that Q is a 3 by 2 matrix. We can check that. So matrix P has 2 rows and 3 columns. I mentioned that. These are the rows. 1 row, second row. Columns, first column, second column, third column. So this one is a 2 by 3 matrix. How about Q? Q has 3 rows. You can see 1, 2, 3. And how many columns? 1, 2. Columns are vertical. This is 1, this is 2. 1, then 2. So it is a 3 by 2 matrix. Now, if you multiply P and Q, we shall get matrix R. Now, I want to find out what is the order of R. We can derive that from here. R is P times Q. Now, P is a 2 by 3, Q is a 3 by 2. Now, you realize that these figures are actually the same. This is the condition. That multiply matrices, this value and this should be the same. So, it has 3 columns here. P has 3 columns. And Q has 2 rows. So meaning that P and Q can multiply. So the 3 and the 3 are the same. We can multiply. Meaning that the product will now be of order, this value which is 2 by 2. So R will be a 2 by 2. This and that. So R will be a 2 by 2. 2 by 2. So R will be a 2 by 2 matrix. Derived from this, that P times Q, since the columns here are equal to the rows here, then the R will be a 2 by 2 matrix. So can we now get the matrix R? We shall just multiply, since we've already found out that the matrices can multiply. So we can now check first row, first column. You can check that. First row, first column. When we are multiplying matrices, we multiply row into columns. First row, first column. So once I take the first row and the first column, realize that we shall have 3 times 1 plus 1 times 0 plus 7 times 5. That's what we shall take. 3 times 1, 1 times 0, and 7 times 5. We proceed to this one here. Negative 1 times 1, 3 times 0, and 2 times 5. We now proceed to this. 3 times negative 1, 1 times 3, and 7 times 2. We come to this. Negative 1 times negative 1, 3 times 3, and then 2 times 2. And what remains is now the computation. So once we compute, we end up with the 38, 14, 9, 14. And this one is actually, a 2 by 2 matrix, as we had earlier said. So R is actually a 2 by 2 matrix. Now that takes us to our next example, which is example 4. We have those matrices provided. So Question 1, determine the order of matrix AB. Now we said that AB is A times B. Now before you get the order of A times B, you must be in position to tell the order of A. You must be in position to tell the order of B. Can you do that? The order of A, try to find out that. What is the order of matrix A? How do you state that? Look at the number of rows and the number of columns in matrix A. How many rows can you see in matrix A? 1, 2, 3. 1, 2, 3. 1, 2, 3. First row, second row, third row. So it has 3 rows. How many columns? 1, 2. So meaning that A is a 3 by 2 matrix. How about B? How many rows do you see? 1, 2. 2 rows. And how many columns? 1, 2, 3. So B is a 2 by 3 matrix. Now we check it here. A 3 by 2, B 2 by 3. So meaning that A and times B is very possible. Why? The number of columns here are equal to the number of rows. You can see it here. These columns here of matrix A are equal to the rows of matrix B. So this is 2, this is 2. They are actually the same. So this is 2, this is a 2, meaning that A times B is very possible. Why? The number of columns in the first matrix should be equal to the number of rows in the second matrix. And the A times B will now be, see this figure that is here, a 3 by 3 matrix. It will be a 3 by 3 matrix. So the product A times B will be a 3 by 3 matrix. So our multiplication should give us a 3 by 3 matrix. So we can now proceed with our multiplication using the same approach, row by column. This time we have to do more work because the rows and the columns are many. So we shall have 1 times 2 plus 2 times 1, which is here. Now we proceed to this. 3, can see the 3 times 2, 3 times 2 plus negative 1 times 1. 4 times 2 plus 5 times 1. Now we proceed. 1 times negative 1 plus 2 times 3. Now we come to this. 3 times negative 1 plus negative 1 times 3. Proceed. 4 times negative 1 plus 5 times 3. We have not exhausted all. We still have this column here. So we shall take 1 times 4 plus 2 times 1. 1 times 4 plus 2 times 1. Now we continue. 3 times 4 plus negative 1 times 1. Then 4 times 4 plus 5 times 1. Now we've exhausted all the rows and all the columns. Now once you get to this level, the most important part is now to compute and get the final answer. So once we do the computation, we can find out if it takes us the same. This is 2, this is 2, giving us 4. This is 6, negative 1, giving us 5. This is 4, 2, giving us 6. This is 6, negative 1, giving us 5. Negative 3, giving us negative 6. 12, negative 1, giving us 11. 8, 13, negative 4, 15, 11. 16 plus 5, giving us 21. So that marks the end of our first lesson on matrices. However, feel free to contact us for more exercises and examples as far as matrices are concerned. However, we have tutorials for all the subjects. You can always reach us on our contacts that have been provided. However, before we look at the exercise, we could also include this question to help us ascertain how we can handle squares. So we have the matrix P there, we have the matrix Q, and we are interested in P squared Q. So once we say P squared in matrices, it means P times P, and that's what we are going to do. So I have the matrix P times another matrix P. That's what we have. Now apply the same concept of row by column. So we have row, then by column, row by column. So we shall take 1 times 1 plus negative 2 times negative 1. We proceed to this negative 1 times 1 and 3 times negative 1. We don't end at that. We shall now take 1 times negative 2 plus negative 2 times 3. We proceed negative 1 times negative 2 plus 3 times 3. And at this level we just compute to give us a 3 there, negative 8, negative 4, and then 11. So P squared Q, we have the P squared, now the P squared times the matrix Q to give us matrix R. So we can check before we multiply, is the multiplication of these matrices possible? We can see that. Is it possible? We can check. How do we check that? How many rows and how many columns are there? So this matrix is a 2 by 2. Why? It has 2 rows and 2 columns. How about the second one? 2 rows and then 2 columns. So meaning that the multiplication of these matrices is very possible. So we can now proceed and use the same concept of row by column. So 3 times 2 plus negative 8 times 0. Then negative 4 times 2 and then 11 times 0. We proceed to this now. 3 times 0, negative 8 times 2. Then negative 4 times 0 plus 11 times 2. We now compute to have 6, negative 8, negative 16, and then 22. So our matrix P squared Q is 6